Imagine an operations agent that must transfer an approved invoice from a legacy web portal into a Windows finance application. There is no supported connector and no usable API. Normally, that would end the automation discussion. Computer use changes the boundary. It lets a Copilot Studio agent see the interface, reason about what is on the screen, and operate it with a virtual mouse and keyboard. The key mental model is not that the agent became an API. The interface itself became the tool surface. The agent observes, acts, checks the result, and continues. Computer use is powerful, but it should not be the first answer to every integration problem. Start by asking whether a stable connector, REST API, or agent flow can perform the action directly. Direct integrations are usually more deterministic, easier to validate, and less sensitive to layout changes. Choose computer use when the required work is genuinely trapped behind a website or desktop interface. In our invoice scenario, that means opening the legacy record, reading visible fields, switching to the finance application, entering values, and submitting the transaction. The graphical interface is the real system boundary. The configuration begins with 4 required fields. Name identifies the tool. Description tells generative orchestration when the tool is appropriate, so it should describe the business capability and its boundary. Model selects the computer-using model that performs the visual task. Instructions define the operational steps, including the applications, URLs, inputs, actions, and expected result. These fields do different jobs. A vague description can cause the agent to select the wrong tool. Vague instructions can select the right tool but execute the task incorrectly. Treat the configuration as both a routing contract and an execution contract. Computer use does not run in empty space. It runs on a selected machine or hosted environment through a configured connection. And generative orchestration must be enabled for the agent. The execution environment is part of the solution architecture. For production work, use a dedicated machine rather than a personal workstation. Keep unrelated software off that machine, apply organizational security controls, and give the execution account only the permissions required for the task. If the agent needs a browser and one finance application, that is the intended boundary. Machine selection, identity, patching, and isolation are design decisions, not setup trivia. Good computer use instructions read like a concise operational runbook. Name the exact website or desktop application. State the important actions in order. Tell the tool where the task begins, what values it should read, which field it should populate, when it should submit, and what output confirms success. Use inputs for values that change on every run, such as the invoice identifier. Avoid telling the model only to process the invoice. Instead, define a bounded observable sequence. Open the portal, locate the approved record, transfer the required values, submit once, and return the confirmation identifier. Credentials determine whose authority moves the cursor. Maker-provided credentials are the default and can be appropriate for autonomous agents, but they use the maker's access on the configured machine. If that agent is shared, callers might act through the original author's permissions. End-user credentials preserve the identity of the person interacting with the agent, but every user must have valid access to the machine and target applications. Stored credentials can sign in to approved websites or desktop applications using encrypted Power Platform storage or an Azure Key Vault configuration. Choose the credential model deliberately and test the sharing boundary before deployment. Build a safety perimeter around the virtual cursor. Use a dedicated machine, least privilege, trusted site and application allow lists, protected stored credentials, and HTTPS enforcement. Access control limits where the model can take actions. However, an allow list does not necessarily prevent the browser from opening an unlisted destination. The model might navigate there, but attempts to interact should fail because the destination is outside the approved boundary. That distinction matters during testing. Verify both navigation and action behavior. The goal is not merely to make the task work. The goal is to make unintended actions difficult, visible, and recoverable. Human supervision provides an airlock for sensitive or potentially harmful work. If the computer use agent detects instructions that could alter model behavior or create unacceptable risk, the run can pause and request human review. Choose a reviewer who is authorized and can actually inspect the relevant activity. A reviewer who cannot see the run cannot make an informed decision. The response is also time-bound. If the request expires without approval, the computer use run stops. Supervision should appear at the point of risk, with enough context to decide. It is an operational control, not a decorative approval badge. The test experience pairs the instructions and action log with a live preview of the machine. Use both sides together. Watch the model's reasoning, the active step, the cursor path, the controls it selects, and the values it enters. In our scenario, confirm that the vendor, amount, and cost center come from the correct invoice before the finance form is submitted. Keep stop testing visible and use it immediately if the path becomes unsafe or simply wrong. Then refine the instruction and repeat the boundary case. A successful test proves more than completion. It shows that the agent followed the intended route and produced inspectable evidence. Computer-using models combine vision with reasoning, so they can sometimes adapt when a button moves or a page changes. That flexibility is useful, but it does not guarantee the correct business outcome. Test the normal path, moved controls, missing data, unexpected dialogs, session timeouts, and destructive confirmation prompts. A moved submit button can be reacquired. An ambiguous modal deserves a different response. The safe design stops, recovers, or escalates instead of guessing through a risky action. Treat adaptability as resilience within a governed boundary, not as permission to skip deterministic checks, test cases, or human review. After a run, use the activity map and transcript to reconstruct what happened. The transcript can show step-by-step reasoning and screenshots captured during execution. Advanced computer use activity data in Dataverse can add session replay, individual actions, cursor coordinates, user context, timestamps, duration, action counts, websites and applications accessed, credentials used, and exportable session logs. These records support troubleshooting, governance, and performance analysis. Review whether the task completed, how long it took, where the model hesitated, and whether the same interface change causes repeated failures. Monitoring turns a sequence of clicks into evidence that can be improved and audited. For AB-620, read the scenario constraint before choosing the mechanism. A supported connector or reliable API points to direct integration. A deterministic multi-step process with structured inputs and outputs may point to an agent flow. A task trapped behind a graphical interface with no suitable direct route points to computer use. Then verify 4 boundaries: instructions, machine, authority, and evidence. Can the task be described precisely? Is the environment isolated and governed? Are the credentials appropriate for the caller? Can the run be tested, stopped, replayed, and monitored? Computer use sees the interface, acts through virtual input, stays inside a governed boundary, and leaves a trail.